Now let us see on how we can differentiate the following functions, and I'll be able to appreciate. And of course we can have to use the power law of differentiation, the product rule, multiple constant, and the sum of the actually differentiation rules that need to be familiarized ourselves with. So here you go. Let's say we have the function, let's say y is equal to 1 over x to the power 3. So how should we have the derivatives of the derivative of this function? So there is need of rewriting first before we differentiate. So in this case, using the laws of indices, this is the same as y is equal to x to the power negative 3. You should have to understand that according to the laws of indices, if we have 1 over x, this is the same as x to the power negative 1. Likewise, if we have 1 over x to the power, let's say m, this is the same as x to the power negative m. And keep that in mind. And you should also have to understand that in this case, we use the power or have it as y prime is equal to negative 3x to the power negative 4. So that is the derivative of which can have it as negative 3 over x to the power positive 4. And that is according to the laws of indices as well. Sometimes you can also have this case as well and see how you can tackle it. Let's say have y is equal to 5 over x to the power, let's say negative 2. So in this case, we also use the laws of indices as well before we differentiate, or have it as 5 times 1 over x to the power negative 2. Because you have to understand that if we have, let's say, mx over, let's say, 5, this is the same as m times x over 5. Likewise, this is also the same as x m over 5. So keep that in mind. So in this case, we'll have to express it as y is equal to 5x to the power, and that should be, in this case, this is the same as 5. And what is this? So in this case, we'll have it as x to the power negative 2, and which is the same as 5x to the power positive 2. Now we can be able to differentiate that. So that is how you can have to apply that on. And of course, you can also use the quotient class, where let's say you can have y is equal to 1 over x to the power, let's say 3. So in this case, you can have the numerator being given as u, that is being given as u, and what is the u prime? We'll have it as l, and the denominator being given as v, that is x to the power 3, and the v prime will be given as 3x squared. And what is the formula for the quotient rule? We'll have it as u prime v minus v prime u divided by, that should be v prime. And I try to substitute that and appreciate the solution, but it should be the same. To be the same. And how about, let's say, if we have y is equal, and that should be, let's say, the cube root of x. Now how should you have this? Before you differentiate, we should have to think of rewriting first using the laws of indices. So in this case, this is the same as having x to the power 1 over 3. Then the power will be applied, and I'll be able to differentiate that on. So keep that in mind. Let's say if we have, and that should be, let's say if we have f of x, and which is equal to, let's say, negative 5x to the power 4, and let's say plus 3x, let's say plus 7. So what is the derivative of this function? So in this case, there is no need of rewriting because it is an open case. Here we use the power law, and also the multiple constant. That will be given as negative 5 times 4, so it should be negative 5, and x to actually 4x to the power 3, and plus 3 plus l, because the derivative of the constant is given as l. So in this case, we'll have it as negative 20, and x to the power 3, and plus 3. Now how about, let's say, if we have this case? How do you think we can have that? Let's say if we have the function y is equal to, and that should be, let's say, 5 over, let's say, 2x, that should be to the power, let's say, 4. You may have it as 2 in this case as well. So how should we be able to differentiate this? So first thing you should have to keep in mind is that if we have, let's say, mx, and let's say to the power n, you know this is the same as m to the power n and the x to the power n. So if that is the case, then the y is given as 5 over 2 to the power 2 in the times x to the power 2 in that way. And this is the same as 5 over 4 times x squared. So in this case, the y is given as 5 over 4 and the times 1 over x squared. Now using the laws of indices, this is the same as 5 over 4 and the x to the power negative 2. Then now we can be able to differentiate this one using the power rule and that of the multiple constant. So keep that in mind. And also on the same case, if let's say we can have, let's say, y is equal to 2, and that should be over the square root of, let's say, 5x to the power, let's say, 3. So how do you think this one can be actually differentiated? So in this case, this is the same as y is equal to 2 over 5x to the power 3 and over to the power half. And also the same as 2 over 5 to the power half and x to the power 3 in the times half, you know, which is the same as 3 over 2. And now you can be able to separate this or have it as 2 over, you know, this is the same as the square root of 5 and the times 1 over x to the power 3 over 2. Then in this case we'll have it as, you know, 2 over square root of 5 and x to the power negative 3 over 2. So from here you can be able to apply the power rule of differentiation and sort of the multiple constant afterwards. Now, how about, let's say, if we have the function y is equal to, let's say, we have it as 2x squared and let's say minus 2, and I say times, let's say, have x to the power 3 and then minus 2x squared, and that should be minus, let's say, 4. So how should you have the derivative of this function? So as you can see, the function is composed of 2 segments, and this is the first segment and this is the second segment. In this case, we should have to, and also being that the segments are multiplying. In other words, we have the product of 2 segments. The first thing, let the first segment be u and the other one, and that should be, and the other one should be given as v. So in this case we use the product law, which states that the y prime will be given as u prime v plus v prime u in this case. So what is the u? We have it as 2x squared and the minus 2 should be, what is the u? We have it as that, and the u prime will be given as, you know, 4x, and the other one has to be v. We'll have it as x squared, actually x cubed, 2x squared minus 4. And what is the derivative of the v? We'll have it as 3x squared minus 4x. So in this case we'll substitute to this formula and simplify where it is possible to and where it is necessary to. And let's say we have this other case as well. Let's say if we have the function being given as, you know, let's say if we have the case being given as 6, let's say 6x squared. This should be x cubed, by the way. Let's say 6x cubed, and I divide by, let's say, 2 minus x squared. Now how should we have the derivative of this expression? In this case, as you can see, it is the expression of x, so which means this expression corresponds to the function of x. So have it as f of x, that which is being given as that. Sometimes can only be given, you know, expression like this, without being given that, without being openly expressed as the function f of x. But basically the variable of the function actually tells whether the function, it is the function of x or whichever the variable the function is actually processing. So in this case we use the quotient law of differentiation, since we have the actually division of two segments. So in this case we have f of x prime, that is the formula for the quotient law, that will be given as u prime v minus v prime u over v square. So in this case the v basically has to be given as the denominator, so have 2 minus x squared. And what is the v prime? We'll have it as negative 2x. So the numerator has to be given as u, that will be given as 6x to the power 3, and the u prime will be given as 18x to the power 2. Then we'll substitute into the actually a formula for the quotient law. So keep that in mind. That is how we can have to differentiate that. And let's say if we have the function being given as, let's say this is the expression x to the power, let's say x actual square of x plus, and that should be, let's say 2b, and that divide by, and that should be, let's say 6x, and the minus 3x squared, in this way. Now how should you have the derivative of this expression? So in this case we should have to decide, the problem has not been openly specified as to be a sort of function, but we should have to see, as you can see, the function expression is made up of actually two variables, the variable of x and also the variable of b. So what should be the function of the, actually what should be the variable of the function? So basically the variable of the function has to be x, so we'll have it as f of x. So that is the function, that is how the expression has to be expressed as the function. So from here we'll have to rely, because you have to see that the components of the problem, where do we need to rely before we differentiate? As you can see, square root of x, this is the same as x to the power 2 to the power half plus 2b, and then divide by 6x minus 3x squared. We'll have that. Then in this case we can be able to differentiate the function, and basically I'll use the quotient law of differentiation. So in this case the u has to be given as the numerator, x to the power half plus 2b, and what is the u prime? We'll have it as half and x to the power negative half. And what is the derivative of 2b? So since the function is the function of x, so it means b is part of a constant, so we'll have it as L. And the other one has to be v, we'll have it as 6x minus 3x squared, and the v prime has to be given as, that should be 6 minus 6x. So from there you can have to substitute into the function for the quotient law, that is u prime v minus v prime u, that is divided by v squared. So you have that. And let's say we have the function, let's say y is equal to, let's say g of x, and we have g of 5 being given as, and there should be negative 3, and we have g of 5 prime, and are now being given as, and there should be negative 4. Now in this case find the equation of the tangent line at the point x is equal, let's say 5, and of the function y is equal to g of x. Now, how should you have that? You should have to understand that in order to have the equation of a tangent line, the general form of the equation of the tangent line is given as y is equal to mx plus c, where m is the gradient and c and the c is the y-intercept. So you should have that. And how should you have the gradient of the function, and which is basically g of x? So you should have to understand that the function you have, it is given as y is equal to g of x, and the gradient of the function is more associated with the derivative of the function. So in this case, we'll have the derivative of the function. And what is the derivative of g of x? We'll have g of x prime. That is the derivative. And the gradient of the function, at actually x is equal to 5 will be the same as g of 5 prime. And what is the g of 5 prime? We have it as -4. So which means the gradient is given as the -4. So that is the gradient. And now there is a need of determining what we call it as. So there is need of determining what we call it as a point on x is equal to 5. What is the point corresponding? Actually, what are the coordinates corresponding to the x is equal to 5? So the first coordinate is the x coordinate, which is given as 5. And what is the y coordinate? G of 5 is given as the -3. That is the y coordinate at the point in that case. Now we have the gradient and the single point. We can be able to have the equation of a straight line or equation of the tangent line in that case. And for more of this stuff, just have to check in my video playlist about the incitations of the differentiation laws. You come across all these things and they won't matter for you. And let's say if we have the case f of 2, let's say being given as -8. And let's say we have f of 2 prime, and that should be given as 3. And let's say we have g of 2, being given as 17. And we have g of 2 prime, and that should be g of 2 prime. Let's say g of 2 prime, let's say it is given as -4. Now, what is the value of f g? And that should be a prime of 2. Now, how should you have this value? So in this case, you should have to understand about, you should have to recall about the arithmetic combination of the functions. So in case you are in need of that one, just have to check in my video playlist on the YouTube channel so you come across this. Now, according to the arithmetic combination of functions, it states that let's say we have the two functions, f of x is equal to y, and the g of x, let's say, is equal to y as well. Assuming that these functions has the same input as x, then the following combinations are true. So in this case, having f of x plus g of x, this is the same as, since the input as x is the same, now this is the same as having it as x the times f plus g. It is the same as that, and which corresponds to have it as f plus g, fx. And likewise, if we are actually subtracting, principle remains the same. And also, if we have f of x over g of x, this is the same as having it as x in the terms f over g. That is the same as that. And likewise, if we have f of x times g of x, this is the same as f g times x. Those will be the combinations according to the arithmetic combination of the functions. Now, in this case, having this expression, this is the same as having it as f of 2 prime times g of 2 prime. And we have all these values. What is f of 2 prime that is given as? Should be 3. We have it as 3. And the times what is g of 2 prime? We have it as -4. So have it as -12. That is the solution. Now how about let's say if we have also this case as well, and see how we can make it up. Let's say we have f of x, should be given as x to the power 3 and the times g of x. By the way, you can have the detailed structure about this concept. Just have to check on my YouTube channel list, actually on my YouTube playlist videos about the incitations of the differentiation laws. You come across all these things. G of, let's say, -7, they should be given as 2. And we have g of -7 prime, we'll have it as -9. Now the question says that we should have to determine the value of f of -7 prime. Now how should you have this? So in this case, the function associated with f, it is given as this. So we should have the derivative of the function. So what is the derivative of the function? So in this case, we're going to use the product rule, since we have the product of x cubed and a g of x. So using the product rule, we have to differentiate this one first. That will be given as 3x squared times g of x. And plus, what is the derivative of g of x? So have x to the power 3 times g of x prime. We'll have that. Then we'll have to substitute f of -7 prime. That will be given as, wherever there is x, or have an input as -7. So have 3 times -7 to the power 2 and a g of -7 and plus -7 to the power 3 and the times, and that should be g of -7 prime. Then we'll have to substitute and simplify that one. So keep that in mind. And now let's say we have this a problem. Let's say we have x of y to the power 3. Y to the power 3 and is equal to 1. Now let's think of making y as a subject formula and differentiate the function. So we'll actually cross multiply. We'll have y cubed is equal to x. Then we make y as the subject to introduce cube root both sides. So I have to introduce cube root both sides. We'll have y is equal to the cube root of x. So in this case, this is the same as x to the power 1 over 3. And what is the derivative? We'll have it as, using the power rule, we'll have it as, being given as that. So in this case, this is the same as having it as, should be 1 over 3 and a cube root of x squared. So that will be given as that. And also let's see it in the same way, whereby we just have to differentiate the function using the implicit differentiation. So in this case we'll have, we have x over y to the power 3 and which is equal to 1. So we'll have to differentiate this part using what we call it as quotient rule. So have it as, so this is given as u and this is given as v. So for that case, u prime, that is being given as 1 times actually a v which is given as y to the power 3 and the minus derivative of y actually cube that will be given as 2y squared, times x times y prime. Since we are differentiating actually y there, we'll have to multiply y prime, and that divide by v squared, which is given as y to the power 3 and over to the power 2, that is given as y to the power 6, which is equal to 0, because the derivative of 1, which is constant, is given as 0. So we'll have to cross multiply and solve y prime. So in this case we'll have y to the power, and by the way we can have it in this case. Of course it is the same, but let me just have to, what is the common factor here? So common factor is y squared, so have y squared out, and y minus, here should be 3, so 3y squared, there should be 3x, y prime, that is given as 0, and divided by y to the power 6. So in this case we'll have y minus 3x y prime divided by y to the power 4, and which is equal to 0. And let me take this one out. So in this case we'll have to make y prime as the subject, or cross multiply here, and that will be given as y is equal to y minus 3x y prime is equal to 0. In this case the y prime will be given as y over 3x, so that is the actually y prime, and that is upon differentiating using implicit differentiation. This is the y prime. While upon making y as the subject, we obtained this as we have obtained this one as the actually y prime. But I should have to understand that this y is the same as this y. If that is the case, then we'll have y prime is equal to 1 over 3 times, and that should be y over x. So in that case we'll have 1 over 3 times, what is the y? We have it as x to the power 1 over 3. There should be x to the power 1 over 3, and over x, like that. Using the laws of indices, y prime is equal to, we'll have 1 over 3 and x to the power 1 over 3 minus 1. That will be given as, y prime is equal to 1 over 3 times x to the power negative 2 over 3, which is the same as, should be 1 over 3 cube root of x to the power 2. So as you can see, the derivative of the second case is the same as the derivative of the first case. Therefore, the derivatives are the same. So keep that in mind. And now let us see also on how we can apply the L'Hopital's law in the following problems. Let's say have the limit as x approaches, let's say 0, of sine x over x. So if you apply the direct substitution, that will be given as 0 over 0. So this is in determinate form. So therefore we're going to use the L'Hopital's law. So since we have actually a fraction case, then we have to let the numerator being given as f of x, that is given as sin x. Then what is f of x prime? We'll have it as cos x, and the denominator has to be given as g of x, which is given as x, and the g of x prime will be given as 1. So according to the L'Hopital's law, it is states that in this case we'll have it as the limit as x approaches 0 of of f of x prime over g of x prime. So that will be the same as the limit as x approaches 0 of what is f of x prime. We have it as cos x. The divide by, that should be 1, which is the same as, should be the limit as x approaches 0 of cos x. So now the direct substitution work, that will be given as, that should be 1. That is the limit. And how about if we have this case? Let's say we have the limit as x approaches, let's say, infinity of e to the power x over x squared. So in this case, the direct substitution will have it as e to the power infinity over infinity to the power 2, which is the same as infinity over infinity. So this is indeterminate form, hence we should have to use the L'Hopital's law. So we have the expression, which is in the fraction form. So in this case, we'll have to let the numerator being given as f of x. So have it as that. Then what is the derivative? We'll have it as, by the way, the derivative of the exponential function with a constant, actually with the base e. Let's say y is equal to e to the power u. The derivative has to be given as the same function times the derivative of the power. So in case you don't know that, but keep that in mind. So what is the derivative of the function? We'll have it as the same function times the derivative of the power, which is given as 1. So have it as e to the power x. Then the numerator has to be given as the g of x, that is x squared. And what is its derivative? We'll have it as 2x. Then according to the L'Hopital's law, have the limit as x approaches infinity of f of x prime, that is given as e to the power x, divided by 2x. Now the direct substitution will have infinity over infinity as well. This is indeterminate form. So we'll have to apply L'Hopital's law again. So we'll have to apply the L'Hopital's law again. So in this case, we also let it as f of x should be given as e to the power x. Then what is its prime? We'll have it as e to the power x as well. What is g of x? We'll have it as 2x. And what is its derivative? We'll have it as 2. Now the L'Hopital's law will be given as the limit as x approaches infinity of e to the power x divided by 2. So in this case, the limit will be given as, or have it as, upon having the direct substitution, or have infinity over 2. That will be given as the infinity. That is the limit. That is according to the L'Hopital's law, as you can see here. So we can have to apply the L'Hopital's law about 2 or more times, based on the case that we have. How about if we have, let's say, the limit as x approaches 0 from line of the function x ln x. So in this case, the direct substitution will have it as 0 times, positive infinity. That's just be given as infinity. So this is indeterminate form. So how should we have it? As you can see here, we have the product of x and ln x. So which is something very difficult to apply the L'Hopital's law. But we should have to express this to be in a fraction form so that the L'Hopital's law can be applied. So you should have to understand that if you have a times b, this is the same as a over 1 over b. Which is the same as a over, b to the power negative 1. Likewise, this is also the same as b over 1 over a, which is the same as b over a to the power negative 1. That is the same as that, as you can see. So in this case, limit as x approaches 0 from light of, we'll have ln x over 1 over x. This is the same as having it as the limit as x approaches 0 of ln x over x to the power negative 1. So in this case, now we can be able to apply the L'Hopital's law. have f of x being given as the ln x. And what is its derivative? We'll have it as 1 over x. And how about the g of x? We'll have it as x to the power negative 1. And what is its derivative? We'll have it as negative to the power negative 2. Which is the same as having it as, negative 1. That should be negative 1 over x to the power 2. Now, using the L'Hopital's law, we'll have it as the limit as x approaches 0 from light of f of x prime, that is given as 1 over x, divided by g of x prime, that is given as negative 1 over x squared. So which is the same as 1 over x, divided by negative 1 over x squared, which is the same as having 1 over x times x squared divided by negative 1, of which you cancel, have it as, and still we should have to keep on having the limit like that, and also we should have now have it as the limit as x approaches 0 from light of, now have it as negative x. Now the direct substitution will give us 0, that is the limit. So keep that in mind. And how about, let's say, if we have this kind of a case, let's say it has the limit as x approaches, let's say, negative infinity of x e to the power x. So how should you have the limit of this function? Now, upon having the direct substitution, we'll have negative infinity, e to the power negative infinity, which is the same as negative infinity times e to the power, now should be times 1 over e to the power, and that should be positive infinity. So which is the same as the negative infinity times, that should be 1 over infinity. So which is the same as the negative infinity times 0, which is in determinate form. So hence we should have to use the L'Hopital's law in that way. So how should you have the L'Hopital's law? So principle remains the same. What we have here, we have the product of the two parts, that is the limit as x approaches negative infinity. Now in this case we'll have it as e to the power x divided by x to the power negative 1, as we have already expressed that one. Then from there you can be able to have it out. And let's say if we have, and that should be the limit as x approaches 0 of tan x, and minus x over, and that should be 3. So in this case the direct substitution will have it as, we have tan 0 minus 0 over 3. But what is tan 0? We should have to understand that the tan is actually the tan is the same as the sine over cos. So you have sine 0 over cos 0, and the minus 0, should just be over 3. So what is cos 0? We have it as 1, and the sine 0 is given as 0. So in this case we'll have it as 0 over 1, that divided by 3, which is the same as 0. That is the limit. And also let's see on how we can integrate some of the problems here. Let's say have the integral of x e to the power, let's say 2x dx. So in this case we're going to use the actually differentiation, but actually integration by parts. So how should we have it? So using the Wade-Liadi. So as you can see, we have the algebra and the exponential. On the Liadi, which one starts? So algebra starts. In this case, algebra should be given as u. So that will be given as x. And what is the du? We'll have it as 1 dx. Which is just been given as du is equal to actual dx. and obviously the other one is given as dv, that is given as e to the power 2x and a dx. And what is the v? So what is the integral of integral of e to the power 2x? So this is exponential function with base e. So you have to understand that the integral of e to the power u du, this is the same as e to the power u divided by the derivative of the power. So in this case it means we'll have it as e to the power 2x and divided by 2. Then using the formula for integration by parts, we'll have it as uv. What is the uv? We'll have it as x e to the power 2x over 2 minus integral of v du. What is the v? E to the power 2x over 2, and what is the du? We have it as dx. So having this one is the same as x e to the power 2x over 2, and the minus half integral of e to the power 2x dx. Now we can have the direct integral of this. That will be given as x e to the power 2x and over 2 minus 1 over 2. What is the integral of this one? We'll have it as the same function, divided by the derivative of the power and the plus c. So this and this will multiply. We'll have it in that way. So keep that in mind. That's how we can have it. And how about if we have, let's say, the integral of x cos x dx? Should be cos 4x. Let's say cos 4x dx. Now how should you have the integral of that one? So we have the algebra and the trick. So on the Liari, algebra starts. So in this case we'll have it as u being given as x. And what is the du? We have it as should be dx. And obviously the other one is given as dv, that is being given as cos 4x dx. So what will be the v? So in this case we're going to use the chain law of integration. In this case we'll have it as the integral of cos, that will be given as sine 4x, and divided by the derivative of the inner function, that is given as 4. In that way, then we have, using the formula for integration by parts, we can have it as uv, that is being given as x sin 4x divided by 4, and the minus the integral of v du. So v du will have it as sin 4x divided by 4 dx at the end. So that will be given as x sin 4x divided by 4 and the minus 1 over 4. We just have to take this one out. So integral of sin 4x dx. Then also apply the same the way we have done it here, using of integration. So have it as x sin 4x divided by 4 and the minus 1 over 4. And what is the integral of this one? Will be given as the integral will be given as integral of the outer function, that is given as the negative cos 4x divided by the derivative of the inner function, which is given as 4. So have plus here at the end. We'll have this times this, and this times this will be a plus somewhere. So that's how you can have it in that way. And this is true for all actually differentiation functions. How about, let's say, if we have the integral of, and that should be ln x to the power 2 dx. So in this case you have to understand that having, let's say, m, it is the same as the m times 1. So in this case we have it as, so in this case we have the integral of, So in this case we have the integral of ln x to the power 2 times 1 dx. That is the same as that. So this is the log and this is the algebra. So that is, so in this case, using the Liadi, we'll have u being given as ln x to the power 2. And what is the du? Now this is about the exponential function with the this is about the natural log function. So use the power, we use the chain of differentiation here. We'll have the power, that is the derivative of the outer function, ln x, 2 minus 1 times the derivative of the inner function, which is 1 over x. By the way, if we have y is equal to ln u, according to the principle behind the derivative of the natural function, this is the same as inner function, derivative of the inner function divided by the inner function. That is the formula. So which means we have y is equal to, let's say, ln x squared. This is the same as y prime is equal to, what is the derivative of the inner function? We'll have it as 2x. And divide by inner function, which is x squared. So that's the principle behind that. So keep that. So in this case, this is the same as having it as 2 over x times ln x. That will be the same. That will be given as that. And obviously the other one is given as dv. So dv will be given as 1 dx. So what is the derivative of 1 with respect to x? We'll have it as x. Then I'll substitute to the formula for we'll substitute into the formula for by parts. uv, that is given as x, ln x over to the power 2, and minus, integral of v du. So v du, that will be given as x. And what is the du? We have it as 2 over x times, that is ln x dx at the end. So this and this will cancel. So what will be that? So in this case, it means, we'll have it as, we'll have it as x ln x over the power 2 and minus, integral of 2 ln x dx. So have 2 outside, we'll have it as x ln x to the power 2 and minus 2 times ln x dx. So there is no direct integral for ln x, so hence we use the by parts again. So in this case we'll have it as integral of ln x dx. So having that, and it is the same as having it as integral of ln x times 1 dx. So now we'll apply by parts again, where we'll have the u being given as ln x. And what is the du? We'll have it as 1 over x dx. And the other one is said to be the dv, that is 1 dx. That will be given as v being given as x. So have the integral of ln x dx, that will be given as uv, that is x ln x minus integral of v du, that is x. And what is the du? We have it as 1 over x dx. So have this and this one being cancelled out. We'll have x ln x minus integral of 1 dx. So what is the integral of 1 dx? We'll have actually x ln x minus x, and in that way then we'll substitute this onto here. That will be the solution. So keep that in mind about that. And how about, let's say, if we have this case, let's say we have the integral of, and that should be x to the power 4 and the plus 7 x to the power 6 and times sine save actually the sign of x to the power 7 minus 3 dx. So in this case, the integral of this one will be the same as, x to the power 5 over 5, and the plus 7x to the power 7 over 7. So by the way, we need to have this. So the integral of this one will be easily done. But now in this case, we use the U substitution of integration. So I thought there was a sort of sign here as being plus or negative. But now we should have to understand that we'll integrate this one using by parts. So let's see, first of all, consider this one. Of course, we can have integral of x to the power 4 on its own dx. That will be given as x to the power 5 over 5, which is okay. And the integral of 7x to the power 6 sine x to the power 7 minus 3 dx. In this case, what is the u? We'll have it as x to the power 7 minus 3. And what is the du? We have it as 7x to the power 6 dx. Then we make dx as a subject. We'll have it as du over 7x to the power 6. Substituting that one, we'll have integral of 7x to the power 6 times sine u du over 7x to the power 6. This and this will cancel. We'll have the integral of, that is a sine u du. What is the integral of sine u? We'll have it as negative cos u in that way. Then come back and substitute for u. We'll have negative cos of x to the power 7 minus 3, like that. Then we'll have to substitute this onto here, and substitute this onto here. Then press C. That will be the solution. So take note of that. That is how we can make it up. Let's say if we have the integral of, that should be 4 times the square of, that should be that of 5 plus 9x plus, that should be 12, that times 5 plus, that should be 9x to the power 7 dx. So in this case, we'll also do it in the same way, where we should have to, integrate each and every part separately. So in this case, we'll have the integral of 4 square of 5 plus 9x. So this is the same as having, should have x here. So we're going to use the u substitution as well, because there is no direct integral for what we have it here. So in this case, we'll have u being given as 5 plus 9x. And what is the du? We have it as, and that should be that of 9 dx. And what is the dx? We'll have it as du over 9. So we'll have the integral of 4 square root of u du over 9, which is the same as 4 over 9 integral of square root of u du. And having that one, it is the same as 4 over 9 integral of u to the power half du. And you can use the power of integration for that case. We'll have 4 over 9 u to the power 3 over 2 divided by 3 over 2. So that will be given as 4 over 9 times 2 over 3, and u to the power 3 over 2. So that will be given as that. So we'll have it as 8 over 27, u to the power 3 over 2. Then we'll substitute back for u. That will be given as 8 over 27. And what is the u? We had it as 5 plus 9x to the power 3 over 2. That is the integral of the first part. And how about the integral of the second part as well? So the integral of the second part, that is 12 or 5 plus 9x to the power 7 dx. So in this case, there's no direct integral for this. So we're going to use the by parts. Actually, should be u substitution as well. So have you been given as 5 plus 9x to the power, no, should be 5 plus 9x. And what is the du? We'll have it as, should be 9 dx. And what is the dx? We'll have it as du over 9. Then substitute back, we'll have the integral of, it should be 12 u to the power 7, actually du over 9. So that will be given as 12 over 9 integral of u to the power 7, that du. And also do the same, like the same way we have done it before. Then you substitute here and this substitute here. You know, that will be plus here at the end, because we do not have the actual intervals there. That is indefinite integral. Therefore, you include plus c at the end. Now, how about, let's say, if we can have this case. Let's say we have the integral of, 4x to the power 3. And there should be just 4x plus 3, and then divided by, let's say, 4x squared, and that plus 6x, and the minus 5 dx. So how should you have the integral of this one? So as you can see, there's no direct integral for this expression. So use the u substitution. So in this case, u will be given as the denominator. We'll have 4x squared plus 6x minus 5. And what is the du? We'll have it as, should be 8x plus 6. And that should be dx at the end. And what is the dx? We'll have it as du over 8x plus 6. So in line with what we have here, having dx is the same as du over what is the common denominator, or what is the common factor, or have it as 2, 4x plus 3, like that. Then substituting, or have it as, or have it as the integral of 4x plus 3, and divided by, and there should be u du over 4 x over 2 4x. That should be over 2 4x plus 3. This and this will cancel. That will be now, that will be now being given as 1 over 2, the integral of 1 over u du. So in this case, we're going to use the reciprocal rule of integration. That will be given as 1 over 2 ln of u, and that is a plus c. Then we substitute back for u. That will be given as that. And also, let us see on how we can differentiate, problems associated with the trigonometric inverse functions. And let's say we have the function y is equal, and should be y is equal to, let's say, cos inverse of, let's say, x. So what is the derivative of this function? I should have this, and that should be, let's say, should be 7 here. Now how should you have the derivative of this function if that is the case? So in this case, we have a 7 as, a coefficient, we just have to differentiate this function, this part of the trig inverse, that is cos inverse of x. So having cos inverse of x is the same as being given as arc sine of x. It is arc cos of x. It is the same as that. Arc, it is the same as being given as arc cos x. So this is the same as cos inverse of x, in case you may need to understand that one. So first thing you have to understand that this is about the derivative of the actually a trig, which is cos inverse. So should be this is about the derivative of inverse of cos. So what is the differentiation key for cos inverse? So first of all, we have to understand about the inner function. What is the inner function? We have it as u, which is given as x. So what is the u prime? We have it as 1. That is the derivative of x. And now what is the differentiation key for the cos inverse? So we have 7. And what is the differentiation key for the cos inverse? So it is given as negative u prime divided by 1 minus u square. That is the differentiation key for the cos inverse. So in this case, y prime will be given as 7 times. What is the u prime? We have it as 1. That will be given as negative 1, divided by 1 minus, what is the u? We have it as x, so we'll have x squared. So which means the derivative of this function, will be given as negative 7 of square root of 1 minus x squared. So likewise, what if, let's say, we have this case? What if, let's say, have y is equal to, let's say, cos inverse of, let's say, x to the power 2. No principle remains the same. What is the u? We have it as x squared. And what is the u prime? We have it as 2x. What is the differentiation key for the cos inverse? We have it as negative u prime divided by. So you need to memorize this step. This actually, you just have to need to memorize the table of, the derivatives of the inverse trigonometric functions. That is very important. So in this case, what is the u prime? We have it as 2x. So that will be given a negative 2x. That divided by the square root of 1 minus, what is the x? What is the u? We have it as x squared. And that to the power 2, have it as negative 2x divided by the square root of 1 minus x to the power 4. So that is the derivative. And what if, let's say, we have this case? Let's say we have the integral of, it should be a derivative of, we have the function which is being given as, let's say, sec inverse of, let's say, x to the power, let's say, 4. So what is the derivative of the sec inverse if that is the case? Principle remains the same. What is the inner function? Is given as x to the power 4. What is the u prime? We have it as 4x to the power 3. Now what is the differentiation key for the sec inverse? Now the differentiation key for the sec inverse, it is given as u prime divided by the absolute value of u, and that times square of u, actually u square minus 1. That is the actually differentiation key for actually a sec inverse. So which means if we have it as u, absolute value of u, it means in case we have the inner function as the negative, we'll have here as the positive. Upon substituting, we'll have it as 4x cubed divided by the absolute value of x to the power 4 times the square of, what is the u? We have it as x to the power 4, and the over to the power 2, and the minus 1. You can simplify that one. And also do it in the same way. Let's say have y is equal to sec inverse of, let's say, x cos x. What would be that? And let's say if we have this kind of a case, and appreciate how we can have it there. And let's say if we have the function y is equal to, let's say, cosec, let's say the cosec, let's say 2 to the power x squared. So now how should you have the derivative of this function? So mind you, this is actually trig inverse, which is cosec. So what is the inner function? We have it as 2 to the power x squared. So what is the u prime? Now this is exponential function with a constant base other than e. So how should you have this? According to the principle behind, we have it as ln 2 and it times the whole function, times the derivative of the power, which is 2x. So have it as 2x times the ln 2 times 2 to the power x squared. Then what is the differentiation key for the cosec inverse? So the cosec inverse, basically has to be given as negative u prime divided by the absolute value of u times the square root of u squared minus 1. That will be given as that. So which means you will just have to substitute. And also try this at your own time. Let's say if we have cosec inverse of, let's say, sin x cos x. What did you say about this? And also y is equal, let's say, cosec inverse of, let's say negative x squared. So what would be that? Try that and see how you can make it up. And let's say we have also this other case as well. Let's say if we have y is equal to, and that should be also, let's say, sine inverse of x. So what is that one? So principle remains the same. What is the inner function? We have it as x. What is the u prime? We have it as 1. And what is the differentiation key for the sine inverse? So in that case, we have it as u prime divided by the square root of 1 minus u squared. So just have to substitute to the function. Should be to the formula and have it away like that. So this is how you should have to understand some of the approaches you can have towards the differentiations as well as the integration. So in case you may need more of these actually problems, just have to go through my my video playlist in the YouTube channel, on my YouTube channel. Then you come across different actually techniques that will really help you to undergo all these things. Thank you.